Good afternoon, everyone. Wow. We got a nice big room, and I really appreciate it. And the worst of my fears is when that's still not big enough. So appreciate everyone being here. So I know I'm supposed to start at 2:10, but I'm going to be honest with you. I have about 3 days of content I'm trying to squeeze into 60 minutes. So we're going to get started like right now. My name's Jeff Woolsey. I'm a principal program manager at Microsoft. I focus on Windows Server and most importantly, hybrid cloud. And it's truly a pleasure to be here. We have a lot to talk about today, so I am going to go ahead and jump right in. The first thing I'm going to do very quickly, to be super clear here, is to talk about, very briefly, about our strategy. As you probably know, you've probably seen a version of this. We've been talking about this, and I could go back 4 or 5 years. But when it comes to our strategy for cloud, it's very simple. We want to make sure it's super easy for you to take advantage on the cloud on your terms. If you want to go to public cloud, we've got Azure. We've got platform as a service, software as a service, infrastructure as a service, but most importantly, we have the things that you want, the things that you care about. Office 365, ML, and hundreds of other services out there, and we're constantly adding more and more. And we know, we hear from you, that a large percentage of customers saying, you know what, my Exchange, I have a team of folks working on Exchange that have been doing this for a while, and they're really good. But you know what? I would really like to focus them on building new apps and driving more value into the business. And so that's a place where we see people saying, I'm going to move my Exchange up to Office 365. I'm going to take advantage of it there. At the same time, customers also say, but you know what, there's stuff that's going to stay on-prem for whatever reason. And I'll give you a few examples. Our own CEO, Satya Nadella, talks about one of the challenges which we have, which is speed of light. Guess what? If I have a piece of manufacturing equipment, or I have a low latency device, or I have to talk to a mainframe, some legacy device, or it's just stuff that's internally that I have to deal with from a latency standpoint, guess what? Cloud may not work for that. So people say, well, I want to be able to continue. I also want to be able to run on premises as well. Well, that's why we have things like Azure Stack. And to be super clear here, Azure Stack is its own category. Every so often someone asks me, well, how does that compare to VMware or HCI? I'm like, stop, it doesn't. There is no comparison to Azure. There is nothing that compares to Azure Stack. It's its own category. It's an extension of Azure so you can run it on your premises, and if you want to build hybrid cloud apps, this is the way to do it. And most importantly, when I explain Azure Stack, I always point out to folks, you can write your applications for Azure, and you can deploy them on Azure Stack. Or you can write them for Azure Stack and deploy them in Azure with zero code change. That is worth its weight in gold. Because now you have a unifying application platform for building new applications that can run on-prem or in the cloud. And you decide what you want to do. Now, at the same time, while people are building new apps, we also know that folks are coming to us and saying, I spoke to a gentleman today after I did the mechanics session who was telling me about an application that they're using in their organization from 1996. It took me everything to not break down and start crying right there. 1996? Are you kidding me? Well, we know that there's legacy stuff that's out there. It's bespoke. Maybe you wrote it, maybe you have the source code, maybe you're working with a partner, a third party that's built and developed it, but you need to still run traditional applications. That's what we've been doing over here with Windows Server and our hyper-converged developments. And that's one of the things I'm going to focus on today in my Windows Server 2019 deep dive, is all the work we're doing in hyper-converged there as well. But my important goal to point out here is no matter how you want to embrace cloud, whether it's Azure, whether it's Azure Stack, whether it's hyper-converged on-premises, we want to make sure we give you the best cloud whenever and wherever it makes business sense, period. I'm not going to walk in and say, you have to deploy Azure. I'm not going to walk in and say, you have to deploy Azure Stack. I'm not going to walk in and say, you have to deploy Windows Server HCI. What I'm going to say is, no, we give you all of the options. And you decide what makes business sense. And guess what? The vast majority of customers are telling me the same answer. So before I give you that, let me ask a simple question to everyone in the audience. I'm just going to look for a show of hands. Okay? Very simple question. What is your organization's cloud strategy? Are you A, public cloud only? Are you B, private cloud only? Or are you C, hybrid cloud? So let's look for a show of hands. What organizations here are public cloud only? Okay? How many of you are private cloud only? And now everyone else. How many of you are hybrid? Welcome to my world. Yes. Guess what? I get the same response every single time. And I've been asking this question for years. Why? Because there is no one-size-all-fits-all solution. And we've been embracing this for years because we know that this is what folks need. So that is our cloud strategy in a nutshell. Well, when it comes to Windows Server, one of the things I like to point out to folks is, by the way, you understand that Windows Server is what underpins Azure. Windows Server is what underpins Azure Stack. All of that software-defined compute, storage, and networking, yeah. Guess what? It's all running the same. It's all running the same. It's the same hypervisor. So when we've been developing Windows Server, guess what? We listen to your feature requests. We listen to Azure's feature requests. And every so often, you get new features, not that you asked for them, but you get new features because Azure asked for them. One of the questions I get asked all the time is, Jeff, why does Windows Server 2016 and 2019 support servers with 24 terabytes of RAM? Does anybody use that? And I said, no, not really, but Azure does. And because Azure said, we need that support, we built it into Windows Server, and you just got it for free. When Azure said, we need the biggest, baddest VMs on planet Earth, we need you to support 240 virtual processors inside of a single VM, that wasn't because customers out here were screaming for it. It's because Azure asked for it. So guess what? You just got it because they asked for it. And so there's a huge benefit in terms of engineering. Well, in Windows Server 2019, we focused on 4 pillars: hybrid, hyper-converged, security, and application innovation. Now, if you saw the Microsoft Mechanics show, I did a ton of hybrid today. That's all I focused on. And so today, I wanted to focus more on some of the other areas, especially hyper-converged infrastructure. So let's get dived in. So really quickly, when it comes to hybrid capabilities, let's be very, very clear here. What we're doing is making sure that if you're using Windows Server wherever you're using it, whether it's a physical machine, whether it's a virtual machine, whether it's in Hyper-V, whether it's in VMware, whether it's in Azure, we want to make sure we give you the best hybrid capabilities, period. And so we're doing things like Azure Backup, Azure Site Recovery. I demoed these this morning, okay? Storage migration services, I'll talk about that a little bit later. And I showed you the Azure Network Adapter today in the Microsoft Mechanics video. We're literally just a couple clicks. We've already configured a point-to-site secure tunnel up into Azure. And this is fantastic for these small environments where you have just a couple of servers. Sure, in your large data centers, you have hardware VPNs and that kind of thing. But what about those smaller environments, schools, libraries, branch offices, where you have just a couple of servers and you still want to securely access to Azure, but you don't have to buy hardware for every one of those branch offices? That's what Azure Network Adapter is all about. And of course, Windows Admin Center, which is our hub for hybrid. So real quick question, how many of you have already downloaded and installed Admin Center and been using Admin Center? Oh my goodness, that is not enough hands. We got to fix that. All right. So first of all, really quickly, before I go too far, this is included with your license. This is included with Windows and Windows Server. So if you're running Windows, if you're running Windows Server, you already own this. There's no additional cost. You can download it here. Please go ahead and take all the pictures you want. That's the link. This is free. You already own this. And rather than talk about it, let me just hop on over here and show it to you. So here is Windows Admin Center. And the thing I want to point out here is this is all running on this laptop. This is a 50 megabyte download. I simply download this, double click, 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 and it's installed here. That's it. No IIS, no SQL, no nothing. It's all running here. Now, if I wanted, I can install it on a central jump box. So if you're in a large organization, you all want to talk to the central jump box, you can do that. But the thing I want to point out here is Admin Center all runs in a browser. That's it. It runs in Edge or it runs in Chrome. That's it. Real simple. So you can see I've got a bunch of servers. By the way, where are these servers running? They're running everywhere. Some of these are actually running in Azure. Some of these are running back at Microsoft. Some of these could be running in my house. Okay? Doesn't matter. So I'm going to go ahead and select one. I've got a bunch of nodes down here called Silver Node 1, 2, 3, and 4. I'm going to go ahead and click on Silver Node 1. And just in case you're wondering, this one is actually running in my office in Redmond. So halfway around the world. okay? So you can see right off the bat, I've got the name of the computer, I've got the domain, I've got the OS that's running. This is one in Windows Server 2019. It's got 24 gigs of RAM. These are the processors, etc. And a lot of the things that you would expect to see in Task Manager and System Properties are all right here, and this is updating in real time. By the way, on the server, no agents. This is agentless. So the first thing a bunch of you thought when you saw this was, this is going to install an agent, so there's no way I'm going to be able to ever install this and run this. No, it's agentless. This uses PowerShell. This is WinRM, PowerShell, and WMI. That's it. So you don't need to install any agents. You literally install this, point it to your server, start talking to your server. Next question I always get is, well, what about security? What are you guys doing? No, it's AD. This is all plugs right in your AD. So if I don't have access to the server, I won't get access to the server. I do have access to the server because I set it up, so guess what? I'm plugged right in. So there is the overview page. Well, let me show you some other things. For example, certificates. Now, if you're used to managing Windows Server traditionally, you're used to having all of these MMCs, okay? You'd have one for events, certificates, devices, and more. Well, here, for example, I can see my certificates. If I want to click on my expired ones, it'll actually give me a list of all my expired. I can actually sort these by expiration date. Here I've got one from October 2005, and in fact, I'm deleting certificates remotely halfway around the world from a web browser with no agents installed on my server. I'm just getting started. All right, let's get going. Devices. You're probably thinking, okay, well, how do I look at devices? Well, you'd normally go to Device Manager. You'd go to yet another tool. Well, here I am in Devices, and guess what? I can see everything I need to see. Here are the network adapters for this. You can see how they're configured. You can see the processors. If I want to see storage controllers. What if you need to update a driver of a server remotely? Ooh, that's a toughie. No, not with Admin Center. You'd simply click on it and click on Update Driver and update the driver remotely. By the way, this is all happening in one pane of glass. I haven't switched tools, I haven't switched context, all in Admin Center. Next, let's get on over here to events. So here, I want to actually see the events happening on this server. So I click on here, and let's go ahead and click on security. Now, this is updating, and you can see it says I have 167,983 security events. Now, normally, I'd be pretty freaked out if you have 167,000 security events, but luckily, we have this thing called the filter button here, and so I'm going to remove the informational and the verbose. I only want to see the critical errors, and in fact, after it applies the filter, you can see that I have 0 critical errors. So everything's all good. So you can see, I've just shown you a whole bunch of things, all staying within the context. I also want to point out about Admin Center, like I said before, that everything you're seeing in Admin Center, this is a beautiful, easy-to-use GUI, is built on PowerShell. And so one of the first things we did after we released Admin Center was we've been asking for customer feedback. And one of the big pieces of feedback everyone said was, Jeff, this is awesome. I'd love to see that PowerShell, though. Okay, so we created a little PowerShell button right here. So if I click on the PowerShell button, it shows me literally all of the PowerShell used by this tool, the event tool. So now you can literally come in here and say, hey, how did we do this get event logs records? And in fact, you can copy and paste this into your own scripts. Want to use this in Azure Cloud Shell? You want to use this on-prem? Guess what? There's your PowerShell. We just gave you the scripts. Pretty sweet, huh? Really? Nothing? Nothing? Okay. I just want to make sure you're awake and I don't need to have coffee brought in. Okay, let's keep going here. So as I mentioned, this is not only a product, but it's a platform too. So every one of these items, these tools, every one of these tools is actually a plugin. So when we started Windows Admin Center, there were actually only a couple of tools in there. And I sit with the Admin Center team, so I literally walked down and talked to a couple devs or talked to a couple of my PMs, and I said, hey, we're working on this tool, and I need a button here, or I need a click here, or I need a tool that does this. And they were like, yeah, we'll have that mocked up for you by the end of the day, and they'd come and go, here are the buttons you asked for, and boom, we have them later in the week, and then we just release them online. So Admin Center is constantly getting updated, and because it's its own platform, we can go here into settings, and you can see here are the extensions we have available. So if you are writing your own software, if you're a hardware partner, if you're a software partner, if you just want to write a cool new GUI for your application, guess what? You can write your own. Okay? We have an SDK publicly available, and we have partners. For example, our friends over at Data On, they're here at the show. They have awesome Data On integration with Admin Center. So you can literally install this in Admin Center, and now you get a new tool called Data On. So when you connect to their servers, you get all sorts of awesome information. We've got Fujitsu's got plugins, Lenovo's got plugins, and more are on the way. So I just wanted to give you a really super quick update of Admin Center because the rest of the demos I'm going to show you from here on out are all going to be in Admin Center, and I don't want you going, what is that thing he's using? Oh, by the way, one other thing I didn't show you. Let me switch to another tab. So this is Silver Node 4. This is another one of the machines sitting in my office, again, in Redmond, Washington. You can see it's running a bunch of VMs. Let me let you in on a little secret. I haven't told you what's actually running on the servers. I haven't showed them to you. How? Well, I'm doing all this remotely, of course. So let me actually head on over here to remote desktop, and you can see these are all running server core. There's no GUI on these. But I'm giving you all the easy-to-use management. You can add roles, you can remove roles, you can configure things, all using Admin Center, and guess what? On the box itself, it's actually running core. So pretty cool stuff here we're doing with Admin Center, with lots more to come. All right, so that's your tour through Windows Admin Center. Let's move from into and by the way, in hybrid that I talked about this morning, I demoed the Azure Network Adapter, I demoed Azure Backup and Site Recovery, but there are others that I didn't have a chance to because literally we ran out of time. Azure Update Management integration. So if you want to basically integrate Azure's update management, yeah, that's all done through Admin Center. We've made that really easy integration. Azure AD, storage replica to Azure, and the storage migration service with Azure File Sync, and I'll get to that in just a minute. And there are more on the way. You're gonna see even more integration. And guess what? These just arrive in Admin Center. They just get updated. We update Admin Center every few weeks. We have an insider preview release, but then we're actually getting ready for a major new release of Admin Centers coming down the pike. And again, it's included with your Windows license. So everything you've seen here, everything I just showed you, that's no cost to you. So again, if you haven't downloaded it, you should. So let's move on to hyper-converged. So hyper-converged is very interesting because if you talk to a lot of folks, everyone talks about how the growth of cloud and how cloud is exploding. And I totally agree. We're seeing it. Azure's growing like crazy right now. But guess what's also happening? People are moving things up into Azure. They're moving and modernizing their applications, and then they go back and they say, okay, we also have these applications that can't move, for whatever reason. Compliance, regulatory, latency, you name it, I need to run disconnected, whatever the reason. Okay, but now they're looking at that going, boy, by the way, these apps are running on servers that are 5 years old, 7 years old, 10 years old. These servers are ancient. They're filled with spinning disks. They got a minimal amount of cores. There's no security on that platform. There's no TPM. There's no UEFI. There's no secure boot. These things are an issue just waiting to happen. So people are now coming back and saying, no, 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 I want to modernize my on-prem as well. While I'm modernizing in the cloud, I also need to modernize on-prem. And so what we're seeing is massive adoption of hyper-converged. So briefly, let me just explain that. So if you look at traditional infrastructure, this is kind of how we've been doing infrastructure for the last few decades. What happens? You buy a SAN, a dedicated storage device. Good chance it's fiber channel, which means you're going to need a storage fabric, which means you're going to have to go and buy some fiber channel switches. Then, of course, you've got your servers for your hypervisors. Then you probably have miscellaneous appliances as well, network appliances like load balancers, gateways, firewalls, all that other stuff. And then, of course, you got your top-of-rack switch. That's a lot of different things to manage. Some of this is bespoke hardware as well. Well, what's happening right now is this is all being moved into the world of hyper-converged infrastructure, where essentially you have standard x86 servers, modern servers with TPM, with UEFI, with flash, with NVMe, filled with lots of flash, filled with lots of cores, filled with lots of memory, and the magic of software. And the software means I have software-defined compute, I have software-defined storage, I have software-defined networking, and everything that required all that special hardware over there we're doing in software. And so you need standard servers and standard Ethernet switches. That's it. And so we're seeing a lot of people going, yeah, that's the way we should do it, because spoiler alert, this is how we do things in the cloud. We do all of this in software. You don't think we actually use SANs up in Azure, do you? No, that's all software-defined storage, okay? We've learned a lot about running at massive scale, and we want to bring this to everyone at different scale points. So what we've been doing with hyper-converged, obviously Windows Admin Center, what I just showed you was managing a single server, but I'm going to show you in just a second how Windows Admin Center does hyper-converged management as well. Yeah, let me say that one more time. Hyper-converged management as well. That's something you usually pay thousands of dollars from the other guys. No, we include it in Admin Center at no cost. Okay, so that's Admin Center management. We actually do 2-node HCI. 2-node, we can go all the way down to 2. When we first launched HCI, we did 4. We thought, that's probably good enough. Turns out a lot of people said, nah, it's not small enough. Really? Why? Well, imagine you're a retail outlet and you've got 1,000 coffee shops. And if you need to deploy HCI in 1,000 coffee shops, the difference between 4 nodes and 2 nodes is huge. And a lot of people said, I can't do 4, that's too big. We tried 3. People said, that's better, but we need this even smaller. We went all the way down to 2. People said, no, we understand we need redundancy, so we need to go down as low as 2. Industry-leading performance and scale, as well as persistent memory support. So, I showed you Admin Center for managing servers. Let me talk about Admin Center as the new face of hyper-converged infrastructure. So what you see now is, again, here's Admin Center. This time, we're going to go ahead and we're going to add a hyper-converged cluster connection. So this is not managing one server. This is managing a cluster of servers. So I'm going to go ahead here. I'm going to paste in the name. It's found the name of the cluster. And you can see this has 2 servers. These are actually data on Kepler 47s. And I go here, click on the Hyperconverged button, and you can see I'm in the Hyperconverged Cluster Manager tool, and check out the dashboard. You're getting full cluster view out of Admin Center. So I can see I've got a couple of alerts, and these are for the cluster, not for a server, and I can view these. I'm running low on storage capacity, so it's telling me that. In this cluster, I have a total of 2 servers. Both of them are healthy. Okay. In this cluster, I have a total of 16 drives. So no looking all around, not having to hunt anywhere. No, it's giving me all the information I need. I have a total of 20 virtual machines. 15 of them are running, 5 of them are off. I have a total of 6 volumes across the entire cluster. All right? If I want to get more information, I can scroll down here and start to take a look at some more individualized resource consumption. For example, my CPU. So I'm using currently 22% of my CPU for the cluster. I'm using about 20% of my memory for the cluster. And in terms of storage, I have a total of 9 terabytes total. I'm using 6 of it. All of this is part of Admin Center. All of this is available. And then at the bottom, the thing you want to be able to take a quick look at is, what's my performance in terms of IOPS? You can see I'm generating about 3,000 IOPS. I'm not doing too much right now, with pretty minimal latency. All of this available in Admin Center. And the thing I want to point out is, you can also change the scale. So if you want to take a look at it from a daily, a week, a month, or even a year, so you can actually look for spikes, you can do all of that. But here's the overall dashboard view of what you get from Admin Center. Now, if you want to break in further and actually take a look at the volumes, we clicked on volumes, and now we can click on inventory. And here you can see here are all of the volumes. Here's my entire inventory across my entire cluster in one location. If I want to offline, if I want to expand a volume, I can do all of this. If I want to delete a volume, I can do all of this from Admin Center. Again, all of this part and parcel, all of this built right in. So again, that's just a quick overview of Admin Center for Hyperconverged, because I'm about to show you much more, and I just, again, want you to be able to set your bearings straight. Now, one of the questions I get asked all the time is, well, wait a minute, how does Windows Admin Center, compare to System Center? Does this mean System Center, I don't need System Center anymore? No. These are 2 different products. They're complementary products. Windows Admin Center, you can literally use anywhere. Anywhere there's a server running. If it's a single server running in Azure, in a VM, on a physical machine, you can run it anywhere. System Center, though, is designed to manage it at scale. If I need, for example, to do bare metal deployment of a rack of servers, that's not Admin Center, that's System Center. If I've built my own custom monitoring for Operations Manager, that's a System Center thing. And in fact, they're complementary and work together, okay? So, HCI Management. Let me give you an example now of what you can do through Admin Center in terms of management and scaling. So, let's just suppose you have a 2-node, like I just showed you, I have a 2-node data on Kepler system, and you can see I've got 2 servers. And so what happens, you can see I'm starting to get full from a capacity standpoint. I'd like to add another server. So what I'd really want to do is I want to plug another server in, and what I really want to be able to do is I want to be able to balance the pool. So I want to be able to bring the new one on, have it take on the load, and reduce the load on the other 2 servers. Pretty standard thing you'd want to do for hyperconverged cluster. Let me show you what it looks like. Let's go ahead and scale out by adding a node. So here, again, are my 2 nodes in my hyperconverged cluster. I'm going to go ahead and add a node. So here comes the 3rd node, DK47N03. Go ahead and select it. I'm going to go ahead and add the server. We're adding the server to the cluster. It's asking me about CRED SSP. That's OK. I'm going to go ahead and click OK on that. It's adding the server to the cluster. You can see it has successfully been added. And now I have the 3rd node added to the cluster. All right? So there is DK47N003. Now, I'm going to go on over here, take a look at my drives in my inventory. One of the things that's really cool about Admin Center is you can sort your drives by server. So you can see, here's the new server. Currently it's 0% because we just added it to the cluster and it hasn't actually rebalanced yet. But what happens is now we're rebalancing the storage pool. And over time, what you'll see is it'll start to drain from the other two and it'll start to fill to the third. All we did was all of that through Admin Center just by adding. Now what about the opposite? What if I need to actually take a node out? I'm gonna go from 3 to 2, and honestly, this is the harder one. Adding is pretty simple. Removing is the challenging one, because you have to make sure that you're carefully doing this to make sure that you're honoring your fault domain separation when you do this. Well, taking out this, going the opposite way should do the same thing. I should be able to drain that node of all of the resources running it, and I should fill it on the other two servers. Okay? So what does that look like? Well, let's scale in by removing a node. So again, I go back to my 3 nodes of HCI right now. I'm going to go on here over to inventory. And again, here's the node we just added. We're going to go ahead and click on remove. And we're also going to remove the server's drives from the storage pool. So go ahead and do that. And so what now is happening is, in a completely managed way, it's going to drain that third node of all the VMs, all of the resources, all of the storage. It's going to balance it back, rebalance it to the first 2 nodes. They will build back up. And when it's done, it's removed from the cluster. All done through Admin Center, all done in a couple clicks. The goal here is to make all of this HCI management really, really super simple through this easy-to-use Admin Center tool. Now, when it comes to software-defined storage, honestly, we've been doing a ton of work here with Storage Spaces Direct. And I could literally spend the next hour or 2 just talking about some of the cool features we've done here. But this is just to give you an idea of just how much work we've been investing in our Storage Spaces Direct technology. Well, one of the things that's cool is we, of course, want to help you reduce costs. Well, how can we do that? Well, deduplication and compression for Storage Spaces Direct. Now, if you're using our storage products in Windows Server, you've known we've had deduplication around for a while. But what we haven't had is deduplication with REFS. It's been limited to NTFS all the way up to Windows Server 2016. 2019 now, you get the best of both worlds. You get all of the automatic healing, detecting and automatic correction of corruptions. You get some awesome Hyper-V features like instant fixed disk creation. You don't have to zero anything out. It is instant and it's secure. You get instant checkpoint integration with Hyper-V because you're using REFS. And now you get all the benefits of data deduplication. And the benefits are tremendous. So we've seen on average, if you're doing documents, photos, videos, things like that, you get about 30% savings. General purpose file server, about 60%. VMs, hard disks, ISO files, yeah, that's not a typo, 90%. And you know how we know this? Because we actually tested this with our own team internally, the Edge team. So the Edge team, for example, is doing a ton of browser testing within VMs. They're doing all this in Hyper-V. And so they're constantly slamming it and doing all of this testing in VMs. So we said, guys, we could really reuse your help. We'd like to apply dedupe to all of your VMs. And they were like, really? Huh, let's see what it looks like. So one of the nice things about Admin Center is because it is running in a browser, you can easily have 2 instances open. So on the left-hand side, we've got a volume with deduplication. You can see 688 gigabytes are used. You can see another one without deduplication. Again, 688 gigabytes used. Go ahead and open this. You can see it's got 63 items. You can see all of the items, including lots of virtual machines. You can see on this same exact volume we duplicated, it's got 63 items, the same exact virtual machines. Because we wanted to show you a true A/B test, okay? And you can see it right here because they are running side by side. So on this one, deduplication and compression, it's a checkbox. Actually, it's a slider button. But go ahead and click on deduplication and compression, and guess what? Let the magic begin. So again, these folders are identical. And again, it's currently using 688 gigabytes of storage. So what we do is we go in here and we enable deduplication, click on the enable dedupe button, and you can see right up here, Admin Center is telling you everything that's going on, and you can see the deduplication and compression begins. Highly multi-threaded, We did a ton of work in 2016 to parallelize this, and we, of course, didn't want you staring at a progress bar for a while. You can see over time, look how much is saved via dedupe and compression. 158 gigabytes. By the way, what's interesting, you can see the throughput here, 190 megabytes read and 3.48 megabytes write. That's because dedupe is primarily a read operation. So we actually get that information below an admin center. So an hour later, after we were done deduping, we saved 611 gigabytes or 89%. Anyone interested in saving that much storage? Anybody? Yeah? Kind of interesting? Yeah. All built in. So you get all of the awesomeness that is REFS, but now you get that coupled with data dedupe, and that's all part of the platform. And you can see it now only uses 73 gigabytes versus 688. And if we click to take a look, you can see from the files and the folders, they look exactly the same. They are the same, but how would you really prove this? How would you really prove that the files are the same? You know what you'd do? You'd run a checksum, right? You'd actually checksum to make sure that they are exactly the same. So that's exactly what we did. We did a string hash and did a checksum. There's the checksum on the right. There's the checksum on the left. It's exactly the same. This is awesome stuff in Windows Server 2019. Awesome stuff. All right, so there is what you're seeing there with 2019. There's so much more. Literally so much more. Okay, I got to keep moving because I'm watching the clock here. Persistent memory. Persistent memory is something I've been watching very closely. I've been so excited about this. So let's talk a little bit about flash memory. Remember when flash memory came out, it was on your USB stick. And your USB stick at the time was USB 1. Okay? Now, it didn't matter because back then the USB was so slow, the flash drive was so slow, it didn't matter that USB 1 was the interface. Then flash got a lot faster, and USB 1 was terrible. And so everybody upgraded to USB 2, and then upgraded to USB 3, and guess what? The flash was still faster. So the problem was, flash was outpacing the I/O. So what did we do? We took that flash and we said, no, we're going to get that out of the way. We're going to attach it to SATA, or we're going to attach it to SAS. Why? Because SATA and SAS, we could push a lot more data through. Guess what? Flash got faster. SATA was now the bottleneck. SAS was now the bottleneck. So what did we do? Well, we took that flash and we said, hey, let's put it on a PCI connector inside your desktop. Well, guess what? Most people have laptops. They have tablets. Guess what? PCI doesn't fit in there. So what did we do? We created a brand new bus called NVMe. Guess what? That's in your laptop. And the flash got even faster. Guess what? Now NVMe is the bottleneck. Well, there's not much where we can go. There's not many places we can go. So you know what we did? We've now taken the flash, we put it on a DIMM socket, and we're plugging it in right next to the processor. It can't get any closer than this. So what's going on? Well, every time flash gets faster, and we continue to get the controller out of the way, get the bus out of the way, guess what? We're reducing latency. And now I can use this as memory, as storage, or as both. You can actually partition it to use it as both. And so with this persistent memory, you can actually use it with our hyper-converged infrastructure. So now all of a sudden we can do some amazing things with this persistent memory because it can look like memory, it can act like memory, or it can look like storage. I can just treat it as storage. So what we did was we partnered with our friends over at Intel. So they've been working on their Intel Optane DC persistent memory. And one of the things we did was we said, you know, we want to take what we've been doing in our software-defined compute storage and networking, and we want to bring this latest innovation, this persistent memory, to what we're doing with hyper-converged infrastructure. And we're going to be the first to do it. So just to put this in perspective, this is Monday, September 26, 2016. This is 3 years ago. Okay? We ran 16 nodes running Windows Server 2016 and set the IOPS record, period. Full stop. No one has hit this number. Now, honestly, this was 3 years ago. I kind of expected by now someone would have hit this number. No one has hit this number yet. I heard a rumor that one of our competitors got to 6 million IOPS, but it took them 32 servers to do it. Ooh, you don't want to publish that. If it takes you twice the number of servers and you're still slower than us, that's not where you want to go. So we did this 3 years ago with Windows Server 2016, and as we started doing HCI and preparing for Windows Server 2019, we called our friends up at Intel and said, hey guys, we want to do this test again. Except this time, we're going to apply Optane DC persistent memory to it. And again, that's what it looks like. You may be thinking, well, Jeff, that's a memory DIMM. No, that's a persistent memory DIMM. Looks the same, fits in the slot. Except there's some really cool, unique advantages persistent memory that you don't get with standard DIMMs. Number one, it's persistent. So when you turn off the server and turn it back on, all that data is in there. There's no load. It's there. It already exists. It's persistent. Look at the sizes. 128 gigabytes, 256, 512 gigabyte, up to 3 terabytes of persistent memory per socket. Whoa! I can do some really cool things with hyper-converged infrastructure. You know who else literally loves this? SQL. Oh. 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 SQL guys all over this. When we told them, hey guys, we're actually putting this in the OS, they were like, you are? Yes, please. We're all over that. Thank you. So we've been working very closely with our friends over in SQL on this. So storage, direct load store, native persistence. In addition, we have full native support in 2019. Okay, it's there. It's already there. It's been shipping. Other folks are still working to catch up. They're still trying to make it happen. We're already done. The work is there. Now, what we did was we contacted our friends at Intel, and we said, guys, we want to run this test. So they sent us 12 Intel servers, not 16. Remember the last test was 16. This is 12. 384 gigs of standard memory, 228-core Xeon Scalable, 1.5 terabytes of Intel Optane DC, 32 terabytes of NVMe, 2 Mellanox, 25 gigabits. This is running Windows Server 2019. This was actually the insider preview. This was like one of the final builds before we actually GA'd 2019. But this is all running Hyper-V, storage spaces, direct, et cetera. And by the way, look at the servers. You'll notice we didn't even fully populate them with storage. So there's plenty of room. If we wanted to add more, we could have even gone further. So let's get started. Here's Windows Admin Center. Again, here's the dashboard. You can see I've got 12 servers total. All of them are healthy. Let's go ahead and click in here. You can see all 12 servers. You can see I've got a total of 72 drives. You can see I've got a total of 312 VMs. Currently, they are turned off. Nothing is happening. 0 are running. Okay? Across this 12 nodes, I have a total of 14 volumes. All volumes are healthy. And if you look at the storage, 91 terabytes of storage. Okay? Currently, only 16 terabytes is really being used, okay? Let's go ahead and click on the servers just to prove it to you. Click on the inventory. You can see here are all 12 servers from our friends over at Intel. If we want to take a look at the drives, we can click on inventory, and you can see, I showed you this earlier, we can actually group by type as well. So you can see all the persistent memory, all that Optane, we can see it across the entire cluster, and you can see it's being used for cache. What's interesting is check out that size, 768 gigabytes. It's kind of a weird size, right? Well, here's why it's that weird size, is because we're actually interleaving. So we're actually communicating with multiple persistent DIMMs simultaneously, just like we would with regular RAM. And then for capacity, here are NVMe drives. And in case you thought NVMe meant they had to be small, well, these are 7 terabytes. These are some pretty good sized NVMe drives. So we're using Optane for cache, we're using NVMe for capacity, and there's our system. Now at the bottom here is the performance. So here is where we actually want to monitor the I/O performance. You can see right now it's not doing anything. 3K IOPS, no VMs are running. Latency is practically nothing here. You can see the system's idle. Nothing's happening. Okay, because I wanted to show you what it looks like before we start the test and you got the lay of the land. All right, you guys ready to see the new IOPS record? Oh, come on, you guys ready to see the new IOPS record? That's what I'm talking about. Give me 1 second here. Before I get started, I'm going to need to add something. Thanks. Just want to be prepared. Again, nobody hit the 6.7 million IOPS. As of today, nobody has still hit the 6.7 million IOPS. Let's get started. So I got my 12 nodes. Let's go ahead and fire up all the VMs running on server node 1, and let's head back on over here to Admin Center. We're going to speed this up because, again, we don't have a lot of time. You can see there's 1 million IOPS out of a single server. Now, for anybody who's been doing IT for a long time, you know how big a crazy that number is. I remember when it took racks and racks of SANs to get 100,000 IOPS. We're doing 1 million IOPS out of a single server now. Crazy numbers. Okay, let's go ahead and fire up server number 2. Guess what? You can see cluster performance, we're monitoring that. You can see that the view scales. So there's 2 million IOPS, and again, almost no latency, 10 microseconds, crazy, that's insane how little latency that is. All right, I could literally do this server by server, but again, I don't have a lot of time, so let's fire them all up. What does that look like? Well, we're gonna speed this up. You can see there's our 3 million IOPS. Again, the number we're trying to beat is 6.7 out of 16 servers. There's 4 million, there's 5 million IOPS. There is 6 million IOPS. Again, teens in terms of latency. 8 million IOPS, 9 million, 10 million IOPS. 10 million, we're not done yet. 11, 12, 13 million IOPS out of 12 nodes. This is crazy performance. Thank you. There's the number, 13,798,000. That was set September 28th with Windows Server 2019 and Intel Optane DC persistent memory. Okay? Double the IOPS with 25% fewer servers. Yes, 25%. Going from 16 to 12, double the IOPS. Okay, now you're thinking, okay, this is really crazy cool. Jeff, I'm sold. I definitely, if I'm not using 2019 now, I gotta start evaluating this thing immediately. Boy, you know what would be really helpful is, how am I gonna migrate my data to 2019? How am I gonna migrate it to a new file server, take advantage of all of this coolness going on in hyper-converged and storage spaces direct? Well, this is an area we've been talking to you quite a bit about. When it comes to storage, you've told us data migration is hard, okay? A lot of people think, well, it's just drag the file on over and copy it. Oh, no, it's much more than that. All the data must transfer, but not just the data, the shares and their configuration, their ACLs, their groups. What about a file that's in use? What about if you, the operator performing the copy, don't actually have all of the permission to actually move these files? What about local groups? What about users? What about data attributes, alternate data streams, encryption, compression? That's all going to transfer. And networking addresses must transfer. All forms of computer naming. Why? I'll tell you exactly why. We've talked to a ton of you, and here's what you told us. People tell us, Jeff, I hate to admit it, but we probably have a server 2003 R2 file server still lying around. Sorry. We have some 2008, we have some 2008 R2, we have 2012, we have 2012 R2, we have 2000. I'm like, wait a minute. You have like every version of every file server we've ever shipped. Why don't these get upgraded? Here's what happens. 10 years ago, someone wrote an application in your organization. And that application's really cool, and it's saving all of its data to a file share. You don't have the source code, you don't have the installation disks, whoever wrote it isn't there, whatever. But you don't know how that application is actually finding that server on the network to save its information there. Is it using an FQDN? Is it using an IP address? You don't know. And more importantly, there are probably other apps like that in your organization. So guess what happens? People say, we're just going to leave them there. So you end up having this trail of 2003, 2008, 2012, and you end up having this trail of file servers. And you keep adding new ones and adding more new ones. But what you really want to do is you want to safely migrate that data to a new file server, but keep all of that information intact. Migration has got to get everything. So what did we do? We came up with Windows Server 2019, the brand new storage migration service. This is about moving your unstructured data from your older file servers to a modern server. It can be either Windows Server 2016 or 2019. Or if you want, you can go into Azure as well, but the option is yours. It's fast, it's consistent and scalable. And the graphical workflow, guess what? It's all in Admin Center. So by the way, if you downloaded Windows Server 2019 and you're looking for the UI for migration service and you can't find it, it's because it's not there. You'll only find the PowerShell. All the UI for storage migration service is built in Admin Center, okay? That shows you all of the new features and functionality for server from here on out is in Admin Center. Okay? So, storage migration service operates in 3 phases. The first thing it does is it talks to your old servers. It says, tell me everything about your old servers. How many NICs, how many volumes, how many disks, how are they formatted, how many shares do you have, how are the ACLs, how are your groups configured? Give me all of that information. I need to know everything. How many NICs, how many IP addresses? Give me all your networking information. How are you identified on the network? The second thing we do after the inventory phase is we want to actually pair this up with the new server, okay? And then we actually want to start transferring that information, all the ACLs, all the files, all that information. But there's a third phase. The third phase I consider honestly pretty magical. The third phase is called cutover. Because in the third phase, what we do is we take the identification of the old server and we apply it to the new server. So if this old server from 10 years ago was called FS01 and had an IP address of 10.0.0.54, guess what? In the cutover phase, it'll name it exactly the same and give it the same exact IP address. We'll rename the old server so you can take it offline, and all of your apps and everything that's looking for this as that name and IP address will automatically go right to the new location. Yeah, this is some cool stuff. Let me show you what it looks like. Let's talk about storage migration. So here is the storage migration service, and again, everything you're seeing is running in Admin Center. So this is like running on a Windows 10 box, talking to my servers. All right, the first thing I want to do is I want to create a new job. So I'm going to go over here, give it a name, real simple. And in fact, just to make this a little bit more difficult, I actually didn't do this with one, I did this with 2 servers. So we're actually going to migrate 2 file servers simultaneously. So the first thing we're going to do is enter my credentials, my admin credentials for the first server. And the first server is FS01. So I'm going to go ahead, I put in my credentials, and I have to be admin to do this, of course, because it's a server, and I need to get everything. So I'm going to add a device. My first server is running 2008 R2, all right? So I'm going to go ahead, and I've named FS01, and I've added it, and the second one is FS02. This is running server 2012. So I'm running I'm going to actually migrate 2 different file servers. And so here I'm starting the inventory process. And what's nice about storage migration service is it's going to literally walk you through the process. At no point do you feel like, oh my gosh, I don't know what to do next. No, it's going to tell you what to do next. So you can see right now, it's actually scanned, it's succeeded, it's given you the information you need to know. And in fact, if I click on FS01, it gives me the details below. Here are all the shares. Here's their location, here's their size, here are their files, and you can see everything succeeded. If I want to click on a share, I can see, is it using caching? Is it using encryption? Am I using shadow copies? There's the volume location. So that's FS01. I can then click on FS02, it's going to give me all the information there as well. And if I click on the configuration information, you can see this is running server 2008 R2, this is the name, FS02 on corpcontoso.com. You can see the OS, you can see the system volume, it's got 1 NIC, it's got 4 volumes. If I want to see the network adapter information, you can see it's got 1 NIC, and here are all of the volumes. So now I've gotten all the inventory information for both my old servers. Okay, so now I'm going to go ahead and I'm going to enter the creds for my new servers. Okay, because I've got 2 new servers, and right now it's a 1-to-1 mapping. The question I always get asked is, can I consolidate? Can I go from 5 servers to 2 or 5 to 1 or something like that? Today it's a 1-to-1 relationship because then again we have to map all of the network naming and stuff like that. So again, we're going to scan this device. Here's 2019-02, and you can see right off the bat, it's auto-mapping all of the FS01 volumes to the new server. So this is the source had CD&E, and you can see the destination has CD&E. You can see below here are all of the shares, and if I decide, you know what, this one that's called C:\old, maybe I decide I don't even want to include it in the transfer. I can even deselect and say, you know, I don't even need to bring it over because I know it's old and we deleted it ages ago. Or if you want to just be safe, you can leave it as is, and it'll all come over. But it's literally simple as checking a checkbox. If you want to remap the volumes, you can, but we will automatically do this for you. So let's go ahead and click on Next, and I'm going to go through the same process of adding the destination device for the second server. So now again, the second device is SMS 2019-03. I'm going to go ahead and scan the destination, and it's going to go through that same process where it's going to auto-map the volumes from the old servers on my file server to the new volumes on my new file server. Next, I can go to the transfer settings where I can literally checksum every single file if you want to go that far. I'm not going to do that for now. And I go ahead and click on Next. So right now we're at the transfer stage and we're about ready to start copying everything over. But before we do, we clicked on the validate button, and literally it's going to validate everything, just to make sure that this is all going to succeed. Guess what? It says, yep, you got enough volume, you got enough capacity, the file systems match, I have all the credentials I need, everything is good, we are ready to do this migration. So again, at no point during this process do you think, oh my gosh, I'm lost, I don't know what to do. So now I click on the transfer button, and literally I am now transferring from 2 old servers to 2 new servers. And if I click to go back here to the main page, you can see the running jobs. So you can see the first one is done, the second one is 28% through, you can see the current transfer speed. By the way, just to be super clear, the file servers themselves are relatively small because we didn't need to watch a gas gauge today during the demo. But you can see the copies are happening, now we're at 79 megabits, and you can see we're transferring 61% through, 94% through, just about finished. Running jobs, 99% through, and just like that, we're done. So we've done the transfer. Now we get to something that's super important. Because if you're an IT pro, if you're an admin, your worst nightmare is getting that call in the middle of the night or getting the call from your boss that says, hey, you know that migration you did? Well, marketing can't find a bunch of files. It looks like you messed up. No. Storage Migration Service has your back. Look at this. There's this cool little feature here called the transfer log. Get to know the transfer log, it's your best friend. Here's why. What happens is when we actually do the transfer, we create this transfer log which exports a CSV file. With this CSV file, then you can go ahead and open this right up in Excel. Well, why do you want to do that? Because when you open this up in Excel, you will see every single file, folder, ACL, everything that happened in the storage migration process. And your boss comes to you and says, hey, you're missing that file. No, I'm going to go ahead and open up the Excel spreadsheet and do a quick search for that file. And when the marketing guy says, hey, you didn't move my file, you can say, actually, you're looking in the wrong directory because I actually did a search in Excel and found the file. And by the way, here's the Excel spreadsheet as proof. These are called giving you the receipts, okay? So the transfer log is all included in here. Again, exports your CSV. So again, you have total confidence in this whole storage migration process. All right. Let's go ahead and move along to finally the cutover process. So again, we inventoried, we transferred, but now we're going to go to the third step, which is, all right, I'm going to configure cutover. So if I want, I can just say, hey, you know what, my new servers, I'm just going to use DHCP. Or if I want to give them a specific static IP address, and if I want to give them a specific name of the server, this is where you do it all. And so now we begin the cutover process. That was the configuration for FSO1. Here's the configuration for FSO2. Configure your destination network adapter. In this case, I'm going to use DHCP. Click on Next. You can adjust the cutover timeout. I don't need to do any of that. Going to keep it its default. And again, before you do anything, we've got a nice big validate button. So before you go through any of this process, click on the validate. Again, we will talk to all of the servers. We will make sure we have all the right ACLs. We have all the right network connectivity. We have everything to do to ensure that this is a successful operation. And so you can see the first one has already passed. The second one has already passed. We have everything. If I want to click it and see all the things we tested, yep, I'm ready to rock and roll. Let's go ahead and close. Click on Next. And now we can get to the cutover process. And so right now, go ahead and close that. Go ahead and click on the Start Cutover phase. And now what's happening is we are making the new servers look exactly like the old servers on the network. Now, one of the things I want to point out is time compressed, because think about what's happening here. We're renaming servers. We're actually rebooting servers. You're actually kicking back with a cup of coffee, by the way, right now, or whatever your beverage of choice is. But this is all being done for you. We are reconfiguring names of servers, IP addresses of servers. We are rebooting servers. So at the end of this, your new servers look exactly like the old ones. They have the same network names, the same network IP addresses, and anything that's trying to locate that file server will go to the right place. The old server gets renamed to another random name so that you can turn it off, stick it in the closet, and whenever you're confident and ever ready to go, stick it in the shredder. And by the way, let me be super clear. The old server, this is a read-only process. So people get worried, what are we doing to touch the old file server? We're not doing anything, we're reading from it. We're not doing anything to actually change the old file server until the very end of this when we're actually renaming it, re-IPing it during the cutover process. So that is the storage migration service. all built into 2019. You can go into an Azure IaaS VM if you want. So if you're saying, hey, you know what? I'd like to go right there, you can do it. You can migrate to Windows Server on-premises, so you can go to a 2016 or 2019 server. And the most popular thing we're seeing people want to do is actually migrate to 2016 or 2019 and then use the new Azure File Sync service to give them a hybrid hot cache file server up into Azure. So you modernize, and then you get a hybrid scenario out of it as well. So this is really, really cool stuff. Guys, is that interesting? Do you think the storage migration service would be interesting to you guys? Anybody? Yes? Awesome. Awesome. Glad to hear it. All right. I'm going to keep cranking along. SDN, a couple things on SDN. I don't have a ton of time, so I'm going to keep this relatively brief for SDN. There are a bunch of new things we added in SDN. Virtual network peering, encrypted subnets, IPv6 support single and dual stack for our SDN now. So it's not an IPv4 world. Nope, we got both v6 and v4 single and dual stack. Fabric ACLs, SDN ACL logging, gateway performance improvements, seeing some staggering gateway performance improvements in 2019. We've learned a lot from Azure. We brought a whole bunch of those improvements down into SDN running in 2019. One thing that came in that a lot of people aren't aware of, I wanted to highlight this, is 802.1x support. So if you're doing, you're looking for this level of EPOL authentication, some people use IPsec to do transparent end-to-end network encryption. Others are still using 802.1x, and so that is now included. It's actually in Windows Server 10, Windows 10 version 1809 and later, and it's in Windows Server 2019. We have documentation on it, but literally it's to enable this, run this from a command prompt. And you can expect that this is a feature you'll soon see in Admin Center, and it's literally check a checkbox and it will automatically do it for you. So 802.1x support in the box. All right, been talking about hybrid, hyper-converged. Let's get into application innovation. So, been talking about, again, a lot of customers are looking at how they can modernize their applications. And sometimes we're going to move it to the cloud. We're going to take advantage of native PaaS and SaaS services. In some cases, it's like, no, I've got something that's got to stay on premises, but I really want to modernize it as well. So there's a whole bunch of things we're doing building on the building blocks of 2016. So for example, in Windows Server 2016, we introduced Windows Server containers for the first time ever, giving you the ability to run Windows Server containers all on a single server. Now we have the ability to run Linux containers as well. So you can actually run Linux containers and Windows Server containers side by side on the same server. We've been doing a ton of work with Service Fabric and Kubernetes for container orchestration. Now that we have the ability to run Linux containers on Windows, it made a lot of sense to introduce the Windows subsystem for Linux to Windows Server as well. So if you're running Bash or there's a whole bunch of things that you want to use your Linux tools for, guess what? You can use those in Windows Server for automation as well. And then we've done a bunch of work around optimized images for Server Core and Nano. But I wanted to make sure I get to this really one cool feature that I think we have done a really poor job at Microsoft letting you know about. So I wanted to make sure I spent a bit of time on this new features on demand. So real quick question for you. How many in the room are using Windows Server Core, either on the host or in the guest? Ooh, good, 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 good. A lot of hands going up. We need to get more hands going up. Now, one of the challenges with Server Core is, there's minimal local tools. So we've been doing a whole bunch of work. You've seen it in Admin Center. Like I said, I showed you that I was actually using Admin Center to manage Server Core. And my goal is to make it super easy to manage server, whether it's running full GUI, whether it's running Server Core, to do it remotely and easily from your client device. But there are challenges, for example, minimal local tools. So what happens, for example, if you need to debug something on a server and it's running Server Core? Okay? Also, installers. There are some apps that literally just go looking for files, just to try and figure out, am I running core or am I running full? Oh, I'm running full, good. Oh, I think I'm running core, I'm just going to fail. They actually don't test it. They just automatically fail because they're scared. Just drives me up a wall. Because in many cases, these apps would just work on core if they would just allow it. So one of the things we wanted to do was we wanted to say, okay, we've got Server Core, we've got full GUI with everything. I want another click stop here in the middle. I want to be able to give you more features, but not go this far, okay? So introducing features on demand. What is it? Well, it's your Server Core, but it's an additional 340 megabytes. There's another ISO that you apply to Server Core. Where do you get it? Well, you can get it wherever you got your 2019 bits. Right next to it, you'll see something that says features on demand. App compat. It's literally sitting right next to the ISO for Windows Server 2019. So what is it for? Well, it's support for apps already in the market, and it's more importantly support for debugging and tools. So here's the installation instructions. You download the ISO, you sign in, and as an admin, you basically insert the ISO, you run this, literally this is the command, copy and paste it, and after the progress bar completes, restart and you're done. Rather than explain this to you, let me show it to you. And of course, I'm doing it here in Admin Center. So here I'm in Admin Center, and I'm running server core in this VM, okay? So guess what? I tried to run mmc.exe, guess what doesn't work? So if you're used to, for example, using your MMCs to debug a local situation, like what happens, for example, if you got an update for a network driver and you can't access the server remotely, you need to be able to debug and solve this problem. Well, if you're on server core and you try and run MMC, it doesn't work. What about event viewer? Guess what? If you type in eventviewer.msc, still doesn't work, okay? What about Explorer? What if I just want to, browse files? You can't run Explorer either. So, what did we do? I now am running the command to add the app-compatible features on demand. So this is literally the command I just showed you on the previous screen. I literally just copy and pasted it, okay? It's going through the process of installing it, 79% through, 83% through, 94% through, and it says, yep, the operation completed successfully. Do you want to restart the server? And click on Y for yes. Guess what happens now? You go to the login screen, it magically turns blue. Just to let you know that you're now running with the features on demand. When you log in and I type in MMC, guess what? I have an MMC. Whoa, it's starting to feel like old home week. Okay, what else do we have? There's Event Viewer. Oh, I could tell the whole room just went, ah. Everybody just went, oh, this feels good again. I know this. I can debug this. There's Event Viewer. There's MMC. There's Explorer. Oh, it feels like old home week again. But guess what? It's not the full GUI. I didn't bring in many gigabytes. No. Okay, I just brought in the things you need to do local debugging. Okay, so that's the core, that's the goal of features on demand. I love this. It's really, really cool. So what I would recommend is, first of all, there are some apps that don't need it. For example, Exchange 2019 actually recommends server core. You don't need the FOD. Exchange 2019 just came out, full support for server core, and they recommend server core. Love it. SQL Database Engine doesn't need the FOD either. It actually works with server core just fine. Has for many years. SQL Server Management Studio, TFS, more to come. Here's what you get in the features of the app compat FOD. MMC, Event Viewer, Perfmon, Resmon, Device Manager, Explorer, Windows PowerShell, Failover Cluster Manager. There's another one here, Internet Explorer, pretend that doesn't exist. Just to let you know, IE is not in the app compat FOD. There's actually a specific FOD for IE. I'm not even going to tell you how to do it. Sorry, not going to do it. Just not going to do it. Please don't put a browser on your server, for crying out loud. You're killing me. Best practice, start with server core. Try it out. That should be your starting point. If it doesn't work, great. Try server core with the features on demand. Simply add it to an existing running server, and there you go. And if that doesn't work, if you have some really legacy thing that says, no, I really need a GUI, okay, then you can go to server with full desktop. I get it. But really, server with FOD, with app compat FOD is a great way in the middle. So finally, let me finish up. Looking forward, I want to make sure every single person in this room knows what we're doing for the next many years with Windows Server. Be super clear. I'm being super transparent about the roadmap. So we have the insiders. Just like Windows 10, guess what? We have it for Windows Server. Every 2 weeks, we release a new version of the insiders release for the next LTSC. So if you want to know what we're doing in Windows Server for the next release, you can already download the bits. Please do that. Also, Admin Center. We release updates to Admin Center every few weeks in the insiders build. Now, we also have this thing called the semi-annual channel build, or the SAC channel. Let's be super clear. This is for containers. Period. Full stop. It's not for Exchange. It's not for SAP. It's not for Oracle. It's not for your infrastructure. It's for containers. Why? Because we update this thing every 6 months. You're not going to upgrade your Oracle every 6 months. You're not going to upgrade your SharePoint every 6 months. No, it doesn't make any sense. For containers, it totally makes sense because it's literally changing out an image file. That's it. So this channel is all about containers. I also want to point out that Admin Center is on the semi-annual channel. So every 6 months, we have a major Admin Center release, which is coming up real soon. Spoiler alert. Finally, we have the LTSC. This is business as usual. This is what we've been doing for the last 10, 15, 20 years. Every 2 to 3 years, you get a new release. Windows Server 2016, guess what? 2 to 3 years. Now we're 2019. Guess what's going to happen in 2 to 3 years? There'll be another release. That's it. It's real simple. Super transparent. When someone says, gosh, I don't know what the future of Windows Server is. No, you do. It is in 2 to 3 years. If you need a container release, you'll have it in 6 months. That's it. So with that, I want to say a huge thank you to everyone. Evaluations, please, can be submitted. If you really liked this session, if you thought it was awesome, my name is Jeff Woolsey. You can follow me on Twitter at WSVGuy. If you didn't like this session, if you thought it was terrible, my name is Jeffrey Snover. Thank you all very much, and enjoy the rest of the time here at Ignite Tour Amsterdam.